Hey guys, very good morning. This is Professor Nehru, Department of Aerospace Engineering, SNS College of Technology. In the Flight Dynamics class, unit number 4, today we'll see the topic on dihedral effect, so which is purely related to the lateral stability. Based on the wing position, the dihedral effects plays a vital role in the designing of airplane, right? So what is the dihedral effect? So let us think that when an aircraft design, where we need to place in a wing in a fuselage. So how we will place whether a straight wing or a slightly deflected in frontward or the back side or upward or the lowerward. When the wing position is either in a upward or in the downward, that we will call it as dihedral. So in the context of aircraft flight, the dihedral effect is a phenomenon of a rolling moment created for side slip. So first we'll understand what is the side slip. When the aircraft axis like longitudinal axis, lateral axis and the direction axis. If the free stream velocity striking outing to the long axis, then we'll see as a free stream velocity with a different angle of attack. Whereas the same free stream velocity striking the aircraft in the side of lateral direction, that angle will be side slip angle and that force we'll call it as side slip. Coming to the dihedral effect on an aircraft, it is largely affected by the dihedral angle. So once you increase the dihedral angle, the positive or the negative, which will plays a vital role in the dihedral effect, especially in the aircraft, which is the angle of deflection of wing from level in the rolling plane. So this dihedral effect is rolling about the longitudinal axis and the wing position. So dihedral angle of an airplane is the upward angle from horizontal of the air wing or tail plane of a fixed wing aircraft. This is maybe considered a dihedral angle in the name given to negative dihedral angle. So this is where there is a downward angle from the horizontal of the wing or the tail plane of a fixed wing aircraft. This is for only in fixed wing configuration, not in the rotary type or in the flapping type. So purpose of this dihedral wing is the upward angle of an aircraft wing from the wing root to the wing tip, where this understanding helps to give more understand of the wing position. The amount of dihedral determines the amount of inherently stability along the roll axis. So how much dihedral is having by the wing configuration or the aircraft, which says how much stable in the roll axis or avoiding the rolling axis or rolling control. From this figure, we have three categories. The wing with lower wing configuration with positive dihedral angle in the port side and the starboard side. Second diagram indicating the dihedral angle is 0 degree in both port side and the starboard side. Whereas the third diagram indicates the dihedral angle which is negative, that is root to the tip is in the downwards. So which is called as negative dihedral or we call it as anhedral position of the wing. All these three technically we can explain by sending the relative wind V infinity in both component like V cos beta and V sin beta. So while sending this V cos beta and V sin beta in leading edge to the tailing edge, whereas in second figure indicates V sin beta and into sin dihedral angle tau. So both sides we have positive and the negative dihedral angle as well as the side strip beta. So two parameters involved here. One is side slip beta and the dihedral angle tau. Let us take the lift at anywhere like delta L position, and this delta will incline in terms of relative wind direction. So coming to the dihedral effect, dihedral is the angle at which the wings are slanted upward from the root to tip. Whereas dihedral stabilizing effect is a result of sliding slide up, which occur when one wing is forced down and other one is forced up. This side slip creates a difference between the angle of attack on the upper and lower wing, with the lower wing having a greater angle of attack, and the rises the lower wing configuration. And now, seeing this diagram, first one is dihedral and the lifting force is slightly inclined towards the gravity position, and this straight and level flight is turned back or banked not in the turning due to the side slip beta. And after that, this inclined lift force and the vertical lift force with respect to center of gravity, this force will be balanced to flight at the third figure. And finally, the lower angle of attack position and the higher angle of attack side, which is unable to control the gust load in the wing platform. So by seeing this rolling moment figure on high wing configuration, the low wing configuration, the alpha is larger in the starboard side and the alpha is smaller in the port side. Whereas in the alpha is smaller in the starboard, while in the low wing configuration, the alpha is larger in the starboard section. Why do we have the dihedral work? Why do we have dihedral work? Which includes the relative wind, high angle of attack and lower angle of attack, which is the opposite to the rolling moment. And these are the various types of dihedral effect which the major contribution in the lateral stability. The first one is straight wing or no dihedral, and second one is have straight wing but dihedral it is having. Third one, the tip dihedral is formed in the winglets, and the polyhedral, the wing position will be have the different angle and different position. These are the types. By coming to the stability criteria, the rate of change of coefficient of side slip with respect to angle of attack or the beta always less than 0, which have the stable curve, and the beta will be is equal to 0, that is a neutrally stable, whereas coefficient of side slip beta is greater than the 0, then it is called unstable condition. So these are the three conditions in the wing position. Next, coming to the sweep angle of the wing, which is giving a greater idea of the wing position, sweep forward or the backward or multiple sweeping angle. We'll take as a bird as an example. Let us take the Swan, Terra and Falcon, all the narrow tapped wing, whereas Swan, Terras have the elegant wing and the Falcon has backward pointing wings. These three are wing position are different category, whereas albatross, eagle, and sparrow have massive wing position, feathered figures, and shorter, rounded wings. So from this, when the bird is in the flap without flapping condition, which is called loitering, and then it's transition to the striking the target or landing, this conversion, the wing position will be changes from loitering to transition, transition to striking position. We can understand the difference of wing position and wing configuration, and which is making the delta wing position. Once the wing positions are in contracted or it's flapped, then the velocity of the bird or the aircraft which will be vary. By seeing the straight wing, it is flying about 31 kilometers per hour. When it is in transition position, it will take 45 kilometers per hour. It's very quick. Whereas once is making as a shorter wing position, then it goes 80 kilometers per hour. Similar to the albatross, and is a fully flapped, then the velocity is 24 kilometers per hour. When it is a transition period, it will go up 31 kilometers per hour, and it will reach up to maximum 80 kilometers per hour once the fully flapped condition. Finally, coming to the angle of sweep, the percentage of root chord to the percentage of root tip chord will be totally creating an angle from the root to tip, right? So these are the final configuration of wing position, where there is a rectangular wing, high taper ratio wing, and sweep back wing. Coming to this, all the aspect ratio lambda is equal to 1, lambda is equal to 0.25, and lambda will be very high in the stall progression. Rectangular wing stall progression done at the root of the aircraft, whereas high tapered wing, the stall progression done in the tip and the mid of the wing, whereas sweep backward stall position done on the tip at the lower end part. This indicates the flow separation of the aircraft. So we will see in the next class about the lateral stability and the direction stability. Thank you.